Okay, so this is the setup diagram for the bell crank lever. This ABC, this is the link which is called as the bell crank lever. It is pivoted at the point B. Then we can apply the weight on the arm AB, that is called as the base arm. So this is external weight. It is connected at distance X. Then spring balance. So this spring balance, it will directly measure the tension. So basically it is used to measure the tension. So this tension is measured in terms of kg value. And then we need to convert the kg in terms of Newton. So we need to multiply this by 9.81 in the calculation. Okay. So this is experimental setup. So when you apply the weight W on the arm AB, this complete bell crank lever will rotate in the anti-clockwise direction. Then by using this adjusting nut, we can create a tension T at point C. Okay. So this tension T, it will create one counter moment to the moment created by weight W. Okay. And when these two moments will become same, the lever ABC, okay, it will bring back to the original equilibrium position. That is the BC will be exactly vertical and AB will be in the horizontal position. So this is our experimental procedure. Now you can note down the observation table. So first column here is serial number. Then in the second column, this is the dead weight. So this is the weight attached on the weight arm, that is AB. So this is W and unit will be kg. Okay. Then the force. So basically this is W into 9.81 Newton. Then X distance in meter. Then distance Y and tension T, that is the required tension at the point C to maintain the equilibrium. So this value will be, it is W into X divided by Y. Okay. And this will be in Newton. So we can conduct this experiment for different weights and different locations. So you can take 5 to 6 readings. So suppose you start from the 1 kg. Okay, so if you apply the weight 1 kg, then you can apply the same weight at different locations. Okay, so its weight value, it will be 1 into 9.81. So suppose we select the X distance. So you can observe in the virtual setup. So here you can observe these are the markings on the base arm. This is 100, 160, 220. Okay, so we can see different locations for the same weight. So let us take the extreme value Okay, so this is 640. Okay, that means we have connected the weight W, that is equal to 1 kg at 640 mm with respect to the pivot point. Okay, so here x distance, it will become 640 mm, that is equal to 0.64 meter. Okay, you note down this simultaneously. So these are the experimental readings. This y distance, it will remain same throughout the experiment. Okay, because the y distance is nothing but the distance between 2 points, that is a pivot point and the point C where the spring balance is connected. Okay, so that distance we will not change during the experiment, so it is the constant value. In this virtual setup, we have selected the distance as a 265 mm. So this y distance, so it is 0.265 meter. So this is y distance. So for the first calculation, tension T, it is equal to this W into X divided by Y. So in the observation table, you have to just write down the final values or the answers. Okay. This calculation part, you can do it separately. So use separate page for calculation. So you can write first number. Okay. So for the first, we have the W, it is equal to 9.81 Newton. Then X is equal to 640 mm, that means 0.64 meter. Distance Y is equal to 0.265 meter. Okay. And by using principle of moment, W into X, it is equal to T into Y. So T, we will get, it is W into X divided by Y. So that is equal to 9.81 into X is 0.64 divided by 0.265. Okay. So we will get some answer for tension T. So the expected value to maintain the equilibrium, okay, T is equal to 23.69 Newton. So if you create this tension T in the spring balance by adjusting this nut, then the spring balance, sorry, bell crank lever, it will remain in the equilibrium position. Okay. So that means we are creating one clockwise moment, okay, which will counter the anti-clockwise moment. So similarly, you can repeat the experiment. So you can change the weight value and also you can change the X value. Okay. So suppose we are repeating the weight 1 kg. So we have selected the same weight. We can change the distance. Okay. So here you can shift this weight at some other distance. So you can select this 400 and you can check the value of T. So every time if you change the weight value or for the same weight, if you change the position, then your T value will be changing. Okay. So select the same weight 1 kg. So force will be 9.81 only. Change the distance X. So take this distance 400 mm, that is equal to 0.4 meter. Okay. Y distance will be same. Everywhere it is 265. That is equal to 0.265 meter. So you can change the weight for reading 3, 4, 5, 6. So change the weight, take this 2 kg. Then this force you can find out by multiplying 9.81. So you can get these values. And you can select the distance x. Okay, so in this fashion, you can repeat the experiment for a different weight and for different distance. Okay, and everywhere you have to find out the tension T value. So this tension T, basically we are doing only the theoretical calculation. We need to observe whether we get the same value by performing the experiment. Okay. So this calculation, this is the principle of moment. Okay. Also, you can repeat this experiment for multiple values on the arm AB. That means you can connect two or more weights simultaneously, and then you can find out the tension T. So you can refer the second observation table. So this is the setup diagram. If you connect the weight W1 and W2 simultaneously on the arm AB, so W1 is connected at x1 distance, W2 at x2 distance. Okay. So here if you apply the principle of moment, then equation will be the clockwise moment, it must be equal to the anti-clockwise moment. Okay. So W1 and W2, they will create anti-clockwise moment, and tension T, it will create the clockwise moment. Okay. So our equation will be tension T into distance y, this is clockwise moment, is equal to anti-clockwise. So it is W1 into x1 plus W2 into x2. Okay. So tension T, it is equal to W1 into x1 plus W2 into x2 divided by y. Okay. So for such type of setup, this is the observation table. Okay, so this is observation table. First column is real number, then second column is weight W1. You can take this weight in terms of kg or you can multiply by 9.81. So that will be in Newton. Weight W2, this is suppose 3 kg. So this is just an example. We have selected W1 as 2 kg, W2 as 3 kg. Then x1 distance, it is for W1, it is 0.2 meter. X2 is for W2, that is equal to 0.15 meter. Okay, and distance y is fixed for the same setup, so 0.265, and then you can get the value of tension T. It is W1 x1 plus W2 x2 divided by y. Okay, so this observation table, if you connect the multiple weight for the arm AB. So similarly, you can change the values for W1 and W2 as well as you can change the value for x1 and x2. Okay, so this is complete experimental procedure. So is it clear to you how to conduct the experiment?